G'day guys, I'm going through this exam question today just because the solutions for it are incorrect and some of the kids that I help out with their schoolwork are freaking out a little bit. So let's go through it. We have to start with, if 200 mils of 0.256 moles per litre sodium chloride solution is mixed with that much sodium sulfide solution, what is the concentration of sodium ions in the resulting solution? Okay, so this is part A. We're looking for the concentration of sodium. Now, to start with, what we're going to have to do is we're going to have to work out the number of moles of sodium total in both of these solutions. So let's start by calculating this number of moles of sodium in the sodium chloride solution. So the number of moles of sodium is going to be equal to the number of moles of sodium chloride, which is equal to the concentration times the volume, or 0.256 times 0.2, which is equal to 0.0512 moles. Great. And then what we're going to do is we're going to work out what the sodium is in the sodium sulfide solution. So we're going to go at the number of moles of sodium is equal to 2 times the number of moles of sodium sulfide. Now that's because we have 2 sodium atoms per sodium sulfide molecule. So that's going to be equal to 2 times the concentration times the volume. And that, my friends, is 0.0498 moles. So now what we're going to do, pretty self-explanatory, we're going to find the total number of moles of sodium, and that's just going to be equal to these two added together. So we're going to have 0.0512 add 0.0498, and that gives us 0.101 moles total. Now, finally what we can do, and I'll put this just over here, we can use this, because this is our total moles of sodium in both solutions. We can then work out our concentration. So our concentration of sodium is equal to the number of moles over the volume, which is equal to 0.101 divided by the volume, which is both of these added together, so 350 mils, or 0.35 litres. Once we do that division, we get a final answer of 0.289 moles per litre to the -1, and this is of sodium ions. So that's part A under control, guys. I'll just clear the screen and we'll get ready to go on part B. So just before I go, our final solution for this is there. Okay, on to part B. So, when chlorine gas is bubbled into a freshly prepared solution of ion 2 sulfate, chloride ions and iron 3 ions are formed. Part 1. Write the ionic equation for this reaction. Okay, so we start with chlorine gas, so that's going to be Cl2, and we'll put our symbols. Chlorine gas, and we have iron 2 sulfate. So in solution, we're going to have Fe2+, and this is going to go to, so the chlorine dissolves into chloride, so we're going to have 2 Cl minus, and we have Fe 3+, and this is aqueous, so is this, and so is this. Great. Now what we have to do is we just have to ensure that we have the correct number of ions, so it has to be balanced. So what we're going to do cool. So that's because of the sulfate as well. That's why I put a 2 out the front of that Fe. Now, it says here, if 0.28 litres of chlorine measured at temperature of 24 degrees Celsius and a pressure of 125 kilopascals is bubbled into 140 mils of iron 2 sulfate solution of concentration 0.396 moles per litre, what will be the concentration of iron 3 ions in the newly formed solution? Okay, so first of all, we are going to need to work out how much in terms of number of moles of each of our 2 reactants that we have. So let's go about doing that. We'll write down our we've got number 2. So let's start with our Cl2, the number of moles of Cl2. Now, to work out this, we're going to use this relationship. PV equals nRT, or the pressure times the volume is equal to the number of moles times this unit of gas constant times the temperature. So we're going to rearrange this, so this is going to be equal to PV over RT, which is equal to 125 times the volume, 0.28, all divided by 8.314, which is our gas constant, times the temperature, and this has to be in Kelvin, so 297 Kelvin. And with that, we get 0.01417 moles. Cool. So we also can work out the number of moles of Fe2+, which is just equal to the concentration times the volume, or 0.396 times the volume, 0.14, and that's equal to 0.05544 moles. Cool. So we need to work out what the molar ratios of these are, and to work out which our limiting reagent is. So for every 1 mole of Cl2 gas, we are going to need 2 moles of Fe2+. Here we have 0.01417 moles of Cl2, and we have way over 2 times more Fe2+. So because of that, we can say pretty easily that Cl2 is our limiting reagent. Cool, and that's just because here we need 2 Fe2 pluses for every 1 Cl2 gas, and we clearly have more than 2 times as many of these. So we're going to run out of the Cl2 gas first. So, because of that, the number of moles, see if we can fit it all in one space. Okay. So, because of that, the number of moles, and we're looking for this Fe3+, is going to be equal to the number, assuming this reaction is 100% efficient, this is going to be equal to, the number of moles of it anyway, is going to be equal to 2 times as much as the Cl2 gas. So is equal to 2 times the number of moles of Cl2, which is equal to 2 times Cl2, 0.101417, which is equal to 0.02834. Cool. Now we just have to work out the concentration of our Fe3+, which shouldn't be too hard. It's exactly the same as we did in the question, part A of this question. So all we're going to do is we're going to work out, well, how much solution do we have? 0.14 litres. So we're going to have the concentration of Fe3+ will be equal to the number of moles divided by the volume, which is equal to 0.02834 divided by the volume, 0.14. So we can say therefore the number of moles of Fe3+ is equal to 0.02 moles per litre to the -1. Okay guys, and that is the final answer to the second one. Now, these aren't very complicated questions. It's just you need to make sure you understand the concept of a limiting reagent, why a limiting reagent works. And if you don't understand limiting reagents, I've got quite a few videos on it, so you just have it. I would just check it out if I was you. But yeah, just wanted to go through this question. They're not too complicated, but if you don't get limiting reagent, or you don't get this part of this question here, you'll never get the second part. So again, guys, I hope this video helped. If it did, give it a thumbs up. But until next time, definitely enjoy your chemistry.